When day 28. Done. Okay. Save preview. Alright, what's this? We are at a point where I can pull that from art. That's the point. Yeah. So it's all pretty much in the build program now. Okay, so as long as we can just pull out the points as two-dimensional coordinates from the art, that's all we gotta do to have collision. Yeah, alright. So I guess, I mean, we are bottom up in the game, and this is top down, so I mean that's probably not that big a problem. Alright, so now we just need to read through this texture, which we already have access to, and locate where the points are, and then put them in the right order into an array, and then pass that array. I mean, write out the array, which I already have the code that does that. Kind of. Well, we need the points, and we need to put the points into polygons, and then the polygons go in stages. Okay, what is this? Shader data, yeah, it's collision rectangles. Here. Alright, so there is the stages, which are not being used. Okay, now let's use them. I mean, really, we do need to pull out the pixels. So wherever that happens, like here, no, that's the glyph. Now here, so here's where we're reading the pixels for the file infos. Well, yeah, we kind of need to do that for both file infos, and so a lot of this code will be just the same. And come to think of it, I suppose even collision can behave in kind of the same way, except that for sprites collision right now is just a, yeah, well, no, that part is different. This code though, this will be the same. So once we encounter one of these cells, it's essentially just that. Layer type info, so yeah. I suppose it's not... What is this? None and collision. Yeah, I think it used to be more than that. Got it down to just those two. Okay. Yeah, I mean, a lot of the code is the same, though. That's... Of course, there's no animations. It's yeah, it's probably better to have a separate loop. Right. Probably, honestly, after much of this. Let's just keep this open then, and go down, and String builder. Okay, so this string builder, I mean, yeah, we're using it all over the place here to write out the various enums and stuff. So yeah, just here. Let's just have another loop, and this will go through stages. Yeah, stages. Yeah, this doesn't need to change. This changes, that's the same. Yeah, we don't really need this art offset thing. We can just kind of do this. Animations are irrelevant. Layer type info is, well, right now everything is collision, so I mean that might not be the case always. But everything in the stage has collision. Okay, so we just go through the frames. Assert that it's not corrupted. Found that's irrelevant. Okay, so there's the chunks. Sure, have that assert. Why not? Oh wait, we need to actually go through the chunks. That's right. Have that assert, why not? And what kind of chunk types do we care about? Well, really only the cell. And okay, so there's the cell and everything else we kind of don't need. Break. Oh my god. So color profile, layer, cell we are handling, and then these two we're not. Palette, old palette, oh, so all of this is just breaking. And then default unimplemented, yeah, sure. And now the cell. Okay, so is it exactly the same? Well, it's kind of the same, right? So this needs to happen, well, let's just write it out, I suppose. This needs to happen, this needs to happen, and all of this needs to happen as well. Yes, 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 so up to here. Then there's art offsets and stuff that, well, actually. No, we do need to know about the position, we just don't need to do that. Okay, so everything up to this point goes out into something. Section misc. I mean, I guess we can put it here. Like, what is this? Parse cell chunk static void parse cell chunk a sprite. Okay, what do we need? Okay, well we do need the chunk. Ace chunk. And we do need the arena to put the pixels into. And that's it. That's it. Okay. So, and the texture is the thing that we're returning. Okay. Texture. Return texture. Okay, so now here we can say a sparse cell chunk arena chunk. I guess it's not really a sparse cell chunk, it's more like decode texture from cell. Okay, so we can just do that. Down here. Okay, there we go. Okay. File info stage. So that's good. Okay. So now we have a texture with the pixels and the width and the height. Of course, it will be the offset is relevant because the pixels actually start at the offset. And yeah, that is kind of a problem though, because I do want the empty. So it's almost like I need to take this image that's in the file and like put it into a bigger image, which is actually the whole thing. Okay, well, let's do that. Do we know how big the whole thing is, by the way? Well, we know how big the cell is. So we know how big this texture is specifically. But how big the whole thing is, I think that's actually in the layer. And you can look at this. So that's a layer. Flags type default width. Really? What else does the cell chunk have? Position X, position Y. Width and height. Yeah, but that's not really... So it has the offset and the position, but I want the whole canvas. Where's the canvas information? It must be in there somewhere. Well, I suppose one file has one canvas, so presumably it'll just be up here. Chunk, color profile, string, layer flag, layer type, chunk layer, chunk cell, ace chunk, ace frame, bytes magic, chunk count old, frame duration for future chunks. Okay, there we go. So the whole file has a width and height. So this is the canvas width and height right here. Yeah. Okay, so we do know what that is then. Okay, so, and we can just allocate that here because there's going to be one of those per file. Okay, texture canvas width. Oh, is it W? What do they call it? Yeah, W. Ace width. Height is ace height. Canvas, what pixels? Arena, alloc, array, arena, what is it, U32s, and canvas width times canvas height. We can also pretend like each of these things has like a filled border. So there's collision on the sort of outside. Yeah, we can do that. So let's just add 1 to each of these then. Pat it out. Pat it out, like that. Yeah. And now we would need to actually fill those then. So we need to fill the first row, which is which now has been padded. So mem set canvas pixels destination value 0x ff and size. How does this work actually? I mean, I guess, I mean, it's not bytes, right? So we can just set all the bytes to that because we want it filled. So how many bytes? Well, it's the width, canvas. Actually, here's a, I suppose the canvas can be the correct size, but I can just like allocate more pixels and then move the pixels pointer itself to first row, first column. Of course, I would bottom up or top down. That's another thing. Yeah, we'll figure that out. So pixels. So first, let's set that first fake row with FFs. And we're going, well actually, if it's, okay, we need to add 2 to both. Alright, so we're going from, so it's canvas width times 2 times size of canvas pixels. Right, it's that. So that's the first fake row. Then we want to set the last fake row as well, and then the columns. Well, plus canvas height. Okay, so plus canvas height would get us 2 rows above, right? So canvas height plus 1. That would be the start of the last row. Because if there are 2 rows total and we add 2, then we need to go by 1. Well, actually, how would we need to go by? So we need to go by 1, 2, 3. Yeah, plus 1. So height plus 1. Times, well actually not times in this case, because this is a U32 pointer. So that gets us to the start of the last row. Value is still FF, and size is still the same, because that's how many bytes there are in the row. Okay, now how do we want to do this? Now we just need to go through all the rows we haven't gone through. For I32 row index is 1. Row index is less than or equal to canvas width plus 1. Row index. These are the rows, so it's 1. So we are ignoring the 0th row. and we're ignoring the very last row, which would be canvas width plus 2. Yeah, it would. Well, hold on. If that's the case, then shouldn't this be plus 2 as well? So plus 0, plus 1, plus 2, plus 3. No, plus 4 would be the very, very end, like pointing out of bounds. Okay, so then this would be 0, 1, 2, 3. So row 3 is with height. Is height plus 1. We want 1 and 2. No, it's just height then. It's just height. 1 and 2. Yeah. There we go. So we want canvas pixels. Well, we want U32 star row pixels. So we have to get that first. So that would be canvas pixels plus row index times canvas width plus 2. Actually, now that the pitch is different from the width, I mean, I suppose if it's the only texture that's like that, it's not really an issue. Maybe, because every other texture we're just looking at it as the whole texture and not modifying them anyway. So yeah, it's probably fine. So canvas width plus 2 is essentially the pitch. So row index times that plus, okay, so those are the row pixels. Now row pixels 0 is 0x ff. And then the last one is also that. The last one, of course, being well, normally it would be like width, the whole width minus 1. That's the whole width minus 1 is that. Canvas width plus 1. It would be like 0, 1, 2, 3. So, yeah, width plus 1. Okay, so hopefully this does what we wanted to do. First row, last row. Let's put a note here. Note. Fill the border. And after filling the border, I kind of want to move the actual pixels pointer. Do I? Well, I mean, yeah, I guess I do. And I suppose we should say canvas pitch is canvas width plus 2 and actually use it. Out as like I65. I mean, it doesn't really matter, does it? Bytes in row. Yeah, that seems right. at the end of this, I want to move the pixels pointer. Canvas pixels is canvas pixels plus, so one whole row, so canvas pitch plus 1, so advance 1 pixel. Okay. Okay, so hopefully that does fill the border correctly. Now that we found a cell, there should only be one of those. I mean, unless there are multiple layers, in which case there isn't necessarily going to be one of those. But I mean, I guess everything that has collision should just be copied. Like, we don't really care about the colors for collision, we just care about what's filled and what's not filled. So, so we don't actually need a full-on, well, I mean, it's not really any different, right? Like, yeah, we can just do a byte array here, but it's not that different. So now this texture needs to be copied into the canvas at the appropriate offset. Okay, well, for what i32 text row is 0, text row is less than texture height, text row plus u32 star row pixels is texture pixels plus text row times texture width. So that's the first pixel of a row, and now we can just memcopy that whole row into the appropriate location. u32 star dest, I mean canvas, well actually well it's a row, right? So yeah, we should be able to just do that. u32 star canvas destination is canvas pixels plus, well actually this, okay, canvas, let's call it top right, top left, canvas pixels plus what? We kind of know this right away, actually. Yeah, we kind of know this right away, come to think of it. It's like we just right here, we can just work it out. Canvas top left for texture is gonna be canvas pixels plus, well actually, no, each one has a separate, each cell has a separate one of those. Okay, canvas top left is canvas pixels plus chunk position cell position y, so that's how many rows there are, times canvas pitch plus chunk cell position X. Yes, that's the top left. Now we can do U32 star canvas row start, I guess. Canvas top left plus text row times canvas pitch. Yeah, and then just copy. Mem copy. Destination canvas row start. Sources row pixels. And size in bytes would be texture width times size of, texture pixels. That. Now we probably need to assert that we can actually, the measurements make sense. So what does that mean? That means that texture once we go to the right, so like chunk, and we kind of know that from in advance, right? Know that here. Assert texture. Basically, texture needs to fit in. So so this chunk cell position Y. I'll check rows first. So chunk cell position Y plus texture height so if it's 3 pixels down and then 3 more, that means 6. So that total size, the maximum this can be, so it's smaller or equal to canvas height. Because the canvas height is actually the correct height. It's width and height. Okay, and similar applies here. Width smaller or equal to canvas width. Okay, so now we know it'll all fit after these asserts, and we can just mem copy. Okay. I kind of want to draw that whole thing to make sure that it's being correctly represented. And I suppose we could, that's the easiest way to draw it. Well, let's see. Alright, so there's our canvas. After this loop is done, the canvas will be filled. So what we could do is we can just go through the each pixel in the canvas for, well, actually we can go through even the border, so like I32 row index is -1, row index smaller, like we can go all the way up to the height, because that also in the canvas height row index ++, and same with the columns. Same with the columns. Col index -1, we can go all the way up to the width. Col index ++, because we have that border. U30, well, actually, first of all, I32 pixel index is row index times pitch, so canvas pitch plus call index. Yeah, that should work. user2 pixel value is canvas pixels pixel index. If it's anything, actually, come to think of it, right? This needs to be zeroed. Do we have 0? Alloc and 0 array, we do. If pixel value, I mean, I guess I can just build out a string, right? So, do we have, like, how are we gonna, well, I mean, I could write out a string, so, but to write out a string, we kind of need to keep track of things. Alright, char star, let's say, temp string is arena alloc array, arena type char count, count the same count as that, essentially. Except we want new lines, so width is actually +3. Oh god. Yeah, temp str pitch okay, so pixel index. Is pixel index going to be... It'd be nice if it was just the same, right? But in order for it to be the same, temp str needs to be moved. Temp str plus temp str pitch. And I guess we can just fill in the new lines right away. Temp string is temp string plus pitch, so that's 1 and +1. Okay, so now the indices are the same. Char is pix value. So if there is anything there, then x, otherwise 0, like that. And the idea is we just do temp str pix index equals char, like that. So we fill it in the same way, except, well, actually no, we can't do it though. We can't do it though, because pixel index, the pitch is different, so, okay, so never mind, let's not do that. Oh, actually, should we do that? I mean, I guess we could. Char index is row index times temp str pitch plus column index. I mean, we can still use the same row indices and column indices at least, so if we move it. So yeah, we can keep it moved. So this is char index now. So this is the character, pixel index, index value, character, character index, and then write to it. And then just output the string. But we want the new lines. We want the new lines though. I mean, we're iterating through it anyway here. So we might as well, at the beginning of each one of these, just set the last character to the new line. Temp str row index times temp str pitch, so that's the start, plus canvas height, so we want to go to the very last one. The very last one would be height. I mean, normally it would be height minus 1. In this case, height is actually height to plus 1. Okay. And right to std out. Okay, well, string temp string, and we want to know how big it is as well, which it's that big, right? I32 temp str lang is that, temp str pitch is that. I mean, that's how many characters there are total. Okay, well, I don't know. Oh boy. Okay, that does something. Certainly. Right, entire file. Arena, path, temp, txt, str, temp, txt, temp str lang. Let's write it to a file. Okay, temp.txt. Okay, so that's a file. That is a big boy file. Okay. What's going on with that first line? Why is this happening? So that's not right. Okay, we can probably reduce the size of the canvas though. A file. Canvas size. Okay, let's make it 100 pixels. Sure. Oh boy. Oh my god. There we go. It's a tiny, tiny stage. Alright. Okay. Now. Oh boy. So this is definitely not doing the right thing. I mean, kind of, right? This looks right. I don't really know how many columns this is though, because status. Does this have column numbers? No. Yeah, we're definitely writing out more than we should be writing out. This is weird. So temp.txt is there because that's the next thing allocated on the arena there. If we just step into this, what do we get? Well, canvas, that's correct, yeah. The pitch is 103, that seems correct. So we go one row and then another one, so yeah, that's fine. Temp string row index -1, pitch is 103, canvas height is 100 plus 1. So 101. Well, oh, actually, no, because that's +2. This one's +2, because it's not the last character, it's like one after the last. Okay, well, alright, well, oh boy. Okay, well that's definitely incorrect. Now there are new lines being written out. It's just they seem to be written out in the wrong place. Okay, what if we break after the first row? Okay, so most of it is null, but that's kind of expected. We don't seem to have written really anything. I guess we could, like, after allocating it, we could memset it with something. Memset this, temp value is the next one, right? So let's set it with, like, it's recognizable. Plus, like, I don't know. Whatever, it doesn't really. Temp string. Okay, let's just fill it with all these pluses. It's like, that's how much we're allocating, that's how much I'm asking to write out. Okay, well there's all the pluses, there's one line, so no new lines, but it's like extra stuff is being also printed, so that's temp.txt, that's the next thing allocated on the arena. There seems to be a new line there. No, actually that's not a new line. It just breaks it there. So if we toggle wrap, toggle word alt-z, yeah, well, alt-z is obviously not gonna work. Wrap show more, yes please. Yeah, so it's one line and it's full of pluses, but pluses only go up to that point, and then it's just temp.txt. What? I don't get it. What's the length of the string? I mean, the length of the string is just gonna be 100 times 100 plus the extra stuff. So that's how much we're allocating. So much. Oh wait. I moved the pointer. So we actually have to move it back now. Temp string minus temp str pitch minus 1. Okay, so that'll solve one of our problems. Okay, so that is the first row. The new line seems to be kind of not in the right place. Can we... I mean, I guess we can. Oops. Well, that's a shame. What's the base R for char count? I don't even really know. Of a string length. Let's find out. Base R string length. It's nchar. That's right. It's nchar. Whoops. Let's try that again. Okay, we got 102. So there are 102 x's, is that right? That sounds right, actually, yes. Because it's 100 for the canvas plus 1 on each side. Oops. Well, if that's the case, if there are 102 x's, then this is not going into that place. because the temperature has been moved by 1, right? So actually this is correct. Okay, so now this is breaking in the right place. Okay. Let's write out the whole thing and look at it. Okay, well, okay, that's not what it's supposed to look like. So it's partially correct. So this is correct. This is not in the right place. It should be at the bottom. But the bottom is just empty. There are no pluses, so we did fill everything. It seems like we just didn't touch the last row at all. Like, whatever happened there. Let's not do this memcopy actually. So the only, like, we're just looking at the border now. Okay, yeah, the border is not being done correctly, for sure. Yeah, okay, so let's just do that first mem set. So the first mem set is correct. And if we turn that off, we should just get zeros everywhere, right? Yeah, this is zeros everywhere. Now we turn on the second mem set, and it sets the second row apparently, but like starting here. Okay. So it does set 1 row's worth of pixels, but like in completely the wrong place. So canvas pixels, at this point canvas pixels have not been moved. So we go by 1, wait, I didn't multiply by the pitch. That would do it for sure. Okay, there we go. So that's been done. Okay, so the first 2 mem sets are working correctly now. That is the first row and the last row. Okay, now this internal one. Yeah. Okay. So it's yeah. So this seems to be doing the correct thing. Yeah. Okay. So at least filling the border works as it's supposed to. Yeah. So filling the border works. Now let's see what on earth this is doing. Okay, it should copy something somewhere. You'd think. But I guess not. It's just empty. Why are we empty? Do we ever hit this place at all? No? No, we're just done. There's no cells? Really? How are there no cells? Where is this? If there are no cells. We want chunk type. Okay, what do we get? Color profile, okay, another color profile, another color. A bunch of color profiles and then that's it? What? Oh wait. I didn't copy the code that actually advances the chunk. Yeah, that'll do it. That code. Okay, now we're failing somewhere here, in fact. Well, let's take a look at what these numbers are. Okay, position Y is 56. Okay, what the fuck? Excuse me? Okay, that's not what I wanted to do when I changed it. Trim contents outside, yes, please, Jesus. There we go. Let's try that again. It's probably gonna, wait, it worked. Did it? Yeah, so the X's do seem to be in the right place. Kind of down the bottom. Yeah. Okay, so the whole bottom up, top down thing seems to be working out for us here. Okay, well. Oops, what? There we go. I suppose I could just keep it here as debug code if false note. Write the canvas out to a to a string for debugging. Okay, now we're just not gonna be doing that. Okay, well. Okay, so the next step would be to go through the canvas. Because at this point we know what the stage is, so now we can go through it, and I suppose we will go through it like that, right? There's the index and the value. And, well, I mean, we kind of want to look at, so in this loop will actually go through the inner part only. Like that. So the inner part, and we want to look at 4 pixels. So we want to look at the target pixel that we're considering, and also its surroundings. And I suppose at this point we kind of have to decide on. So this is a pixel. So if we're looking here, this is like 0, right? Coordinate 0 on the x-axis, and this would be the top of the world. So 0, if there is a wall at 0, like here, I suppose, yeah, we're talking about the left edge of the pixel. And so that's for left and right. Up and down, though, if there's a wall at 0 on the y, that means we're talking about the bottom edge of the pixel. So yeah, so for any given pixel, we want to know if there is a wall on the left edge and the wall on the bottom edge. Because this pixel's coordinates would be like 0, so we're talking about the left edge. And this pixel's coordinates would be 1, and we're talking about the left edge. So with this arrangement, we would have to detect the wall here. So once we're looking at this pixel, we have to look at its left neighbor, see that it's filled, and this one's not filled. Therefore, there is a wall. And the wall's coordinate corresponds to the left edge of the pixel, which in this case is 1. That's a 0, this is 1. Yeah, okay. so this pixel is here, then top, left. Actually, which neighbors do we need to? Definitely need to look at the left neighbor. So pixel value left would be pixel index -1. So we want this pixel, we want the left pixel. As for top and bottom, we want to look at the bottom neighbor. Do we? I mean, this, in world space, this would be 0. And this would be 1. So a wall here would need to be detected by looking at this pixel. And specifically its bottom neighbor. Okay, so is it though? I mean, if you always look at the left neighbor, how do you detect? How? Yeah, so even without the top-down flip, if you're always looking at the left neighbor, well, I mean, if you look at the left neighbor and you find the left neighbor is empty but you are filled and there's a wall here, and you can just do that until the fake row, until the fake column at the end. Okay, so you can detect this wall by looking at this pixel and the left neighbor and seeing that you're not filled, this is filled, so that's a wall. Now that information is there. Then you advance and you look here and here. This is filled, this is not, there's a wall here. This is not filled, this is filled, there's a wall here. So even though this pixel's coordinate is 1, the actual wall would be here. This is 0, not filled, 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 not filled. Yeah, it's just the orientation of the wall is different, but the presence, like the wall is still in the same place. Yeah, so whether this is filled and this is not, yeah, yeah. Okay. And you would do that until the fake row. So that means that we are not just iterating through to the width, we are actually going on the columns at least. We're starting at 0 and we're going up until the fake one, which is like that. On the rows, on the rows, I guess bottom up, well, I mean, it doesn't really matter if it's bottom up, top down, right? On the rows, we have to kind of do it the opposite way. We have to start from the fake row and go, because we're looking at the bottom neighbor. Looking at this pixel, like this pixel and the bottom neighbor, and this pixel and the bottom neighbor. So we are not going up to the fake row, but we are looking at the bottom neighbor. So we are starting from the fake row and going one below that, yeah. So for the top, row index -1, that would be the top. We would look at that and the bottom. And with that information, we kind of know, like with this pixel, you would look here and here to determine that there is a wall. You would look here and here to determine that there is a wall. And then, depending on which is filled and which is not, that would determine the orientation of the wall. And, well, I mean, if we do it this way, each pixel will have like a little wall on it, which is not optimal, of course, but that's a start. So let's just have a pixel for debugging, I guess. So just one pixel collisions everywhere, like in the corner. Well, like in the, well, I mean, should we start with the corner? No, it's one away from the corner here. There you go, so it's just one pixel cluster. If we can just pull that out, that would be nice. Pull that out into walls and collide with them. Well, collide with them. It's going well. Yeah, alright. So pixel value left and pixel value bottom. We have top down here, so bottom would actually be pixel index plus canvas pitch. Because we're going sort of top down, so yeah. Top down. So when we wrote out the string, the first thing we wrote out was the top. Yeah, so we had top down. Alright. So with these three values, we kind of know all we need to know. So for the left and the right, so if pixel value I mean, it's filled versus not filled, really. So if pixel value, like if we are filled and our left neighbor is not filled, I guess bool pix filled is pix value isn't 0. And pix filled left, bottom. Okay. Now, if pix filled and is not the same as pix filled left, there. So this means the filled status is not the same, that means there is a wall. Pix filled bottom, so okay, there we go. If pixel filled isn't the same as the left, that means we have a wall, and the wall's coordinates are, so what is the coordinates of this thing? Well, they're 198. They're 198. So one, like if we take 1 to refer to the left edge, that means the axis for both of them will be just the coordinate of the pixel. And well, I guess we can just write out the corners here. V2 pixel top left, well, actually, we don't really need to do that, right? We just need left, right, yeah. F32 pixel left is column index, and F32 pixel right is column index plus 1. Do we actually ever care about pixel right? No. And F32 pixel bottom, because we're looking at the pixel and its bottom neighbor. So pixel bottom, what's pixel bottom? Okay, well, this is the well, 0 means, yeah, pixel coordinate. Like, as long as, for now we're staying in that top-down system that ASPRite uses, so in that case pixel bottom would be just the pixel coordinate. So row index plus 1 actually, because the first fake row would be one below. It would be 0. Like the minus 1 row should correspond to the 0 coordinate. Oh, God. Okay, so pixel left and pixel bottom I figured out. Now, if pixel filled isn't the same as pixel filled left, so if this is not the same as that, then the 2 points that are relevant are this one and this one. So top left. So we do kind of need to know. No, we do need to know right, and then pix left, pix right. Pix right is pix left plus 1, and F32 pix top is pix bottom minus 1. I mean at this point we might as well just do it this way, right? Pix top is row index and pix bottom is pix top plus 1. Yeah, I suppose we should just stay in top down as long as we can. Okay. V2 P1 is top left, pix left, pix top, and P2 is pix left, pix bottom. Okay, so these are the 2 points. Now we just need to put them into the into whatever array we should be building out at this point. And we need to put them in there in the right order. Yeah. Well, alright, so first of all, let's see if we actually get here. Alright, we do. Left 0, right 1, top 0, bottom 1. Okay, so we're detecting the edges, of course. So this is like this edge, I guess, top 0. What is this? Add to watch. Add to watch. Add to watch. Add to watch. 0, 1, okay, left 0, right 1, top 0, bottom 1. 0, 1, 0, 1. Yeah, so it's this pixel. And we're looking at its coordinates, okay. And we entered in here specifically, so it's left and then top, bottom. So left would be 0, top would be 0, so it's this little segment of a wall that's being detected, which is correct. Yeah, we do want that. Of course, we're gonna get a lot of those segments. We're gonna get a lot of those segments. We should probably skip the border right now and just do the internals. So what does that mean? That means if row index is -1 or row index is canvas h-1, and the bottom namer, this and the bottom namer. Yeah, so the very edges. Or call index is 0, or call index is canvas width. Continue. So this is like, this is a temporary thing. Remove. Ignoring the edges of the canvas. Yeah. Okay, what I was, alright, now 198. 198 and it's gonna be 199. Should be this pixel. Okay, so what are its coordinates? 198 and 99. No, well, 99 is, it's 198, 199. Okay, that seems correct actually. Now these need to go into an array, and and they need to go in the right order. So if pixel filled, that means that the wall is on, the normal should be that way, and our convention is we go from here to like the vector that goes along here. If you rotate it in the xy, then you get normal, so counterclockwise. Well, at this point we do need to worry about world space coordinates actually, because these are like A-sprite space coordinates. Actually, if we just flip them like way later, is that still gonna work? And all we gotta do is subtract the all we gotta do really is subtract the height from, like, instead of being 98, instead of being, what is this, 99 should be 0. So and 98 should be 2. So height minus 1. Height minus whatever coordinate this is, minus 1 gets us where we want it to be. So height minus 1, okay. Height minus 1 minus the coordinate. So it's just row index really that's affected by that. Okay, so okay, let's try flipping it here then. Go bottom up to follow world space. So if we do it at this point, then it will be height, well, canvas height minus 1 minus row index. Okay, so what happens to row index minus 1 actually? Well, canvas height minus 1 minus minus 1, so that's just canvas height. So like 100. And what do you want 100 to correspond to? Is that still pixel top? Okay, so well, if you think about row index 99, so that's the maximum one that we're going to, 99. That would correspond to 0, but 0 is the bottom, so it actually is the bottom, yeah. And this is the top. So now we're bottom up, so bottom plus 1 is the top. Okay, so what happens to minus 1 again? So it's canvas height. So the bottom ends up being 100. Minus 1 minus 99, that's 0. Minus 1 minus 99 is 0, and if 0 is this, then yeah, it should be fine. If 0 is this edge, then that kinda seems correct. But then at the top, this is coordinate 0, so actually should we be looking at the top neighbor then? No, if we're looking at the left neighbor and the bottom, no, that seems correct. But we're starting here at the fake edge, then shouldn't we be like conceptually starting here at the bottom edge? Well, actually that is kind of what's happening. Like row index minus 1. Row index minus 1 is actually at the top of the canvas. Like it's the very top of the canvas. So whereas row index 99 is at the very bottom. And pixel top would be 1. Well, I mean, pixel bottom will be 100. That is actually correct, yeah. Pixel bottom will be 100. Because the one before that, so this bottom is 99, so this top is 100. So for this pixel, the bottom is 100. Yeah, that's fine. That is correct. Yeah. Okay, I think this checks out. Okay, now, if pixel is filled, well, first of all, do we have, like, yeah, right, there we go. So if the pixel is filled and the left neighbor is not filled, what are we? It's eraser. So if this pixel is filled and the left neighbor is not filled, then now that we're in bottom up, these need to go bottom up, I believe. Yes. From here to here, and we have to rotate it. From here to here, and in the XY, alright. Well, then it's bottom, top. If pixel is filled, then it's bottom, top. If pixel is not filled, as the case is going to be here, then it's top, bottom. Well, we kind of need to store this in an array somewhere, so let's just do that. Let's just do that. Let's have an array. Yeah, so this is what we are working on. Okay, all of this actually. All of this is what we're trying to build out. Here. Okay. I'm gonna go take a break real quick. I have zoom it. Yeah, I have zoom it. Alright. Now, can we finish the collision points? So collision points needs to be, we don't know in advance how many we're gonna have. So let's have an array. Let's have a dynamic array of those. Actually, for now, what we can do for now, right, is we can just take this, put it down here, say pull from art here. So, and just put the points in. Just put the points in. Yeah, so this is going to be a struct, v2 star pointer, i32 length capacity, and capacity is going to be some large number, I guess. I mean, well, okay, well, you know what, for now we don't really need it to be a large number. So just that, and then collision points, pointers, arena, alloc array, arena, type is v2, and count is collision points capacity. Okay, so that is our array of these things. Now to hook it up to the rest of the things. This already works. Yeah, this already works. Okay, so then just put these points in. So if pixel is filled, the pixel is filled, then it's top bottom? No, bottom top. Yeah, bottom top. Comparing pixel and what's on the left of it. So it's bottom top situation. Collision points bottom top. Otherwise it's top bottom. If the pixel is not filled, then it's top bottom. Okay, so this will put some points into I mean, we can't really. We're gonna be duplicating a lot of points. Yeah, well, we're gonna be duplicating a lot of things. Doing it this way. And, yeah, this is. Yeah, this would need to be changed substantially, right? Because we only want each point on the polygon to appear once. So we're gonna have to do something more interesting than just what we're doing right now. So let's temp stop putting points in. how do you do it? Yeah. Remove once a proper edge determination proc is done. Oh, at least it's figured out. So right now we'll just add 2 points from the 1 pixel that's in the art, and I guess I'll just put a big to do here. To do figure out how to do this properly. We should to do this to walk around all the polygons properly while only figure out all polygons, adding each of their points to the array once in the right order. There we go. So right now we're just adding 2 points and that's it. Okay, and this is compiling. Yeah, this is kind of irrelevant. So this will add some points somewhere. Okay, collision points. Length 2, 1, 1, and I mean, okay, what is this? 1, 1, and 1, 2. So it's 1, it's 1 and 2. And yeah, I mean, that is kind of what we want, yeah. Yeah. Okay. Yeah, that's right. Okay, well there it is. That's something. That is, we pulled it out. We pulled out a wall. It's 1 pixel. We're only colliding with it. Well, are we? We're kind of colliding with it from both sides. Interestingly enough. How does that work? Okay, I don't really know why we're colliding with it from both sides like this. Is something wrong with our walls, just like in general, or what's going on there? I don't know. Or do we just have bidirectional walls now? Are all of our walls bidirectional? What? Okay, that's kind of weird. Go through the polygons. Collision line. Okay, well, I mean, how many of these are there? 2. I mean, 2 lines. Oh yeah, because it's a polygon, right? So it's not a line. So it goes top, bottom, and then bottom, top. So there are 2 walls in there. Yeah, okay, that explains it. That explains it. It's not a bidirectional wall. Actually, that is interesting. So if you do it this way, then just a 2-line polygon is actually bidirectional. And that's probably fine. There you go. Okay. Well, this is working kind of the way it's supposed to. So let's just commit that. Now, generated code, of course, is has a bunch of errors in it, so they're like not real. Primary sidebar. Okay, so this just got changed a little bit. This got changed a little bit as well. There's only 2 points. Yeah, so let's pull that out. Yeah, pulled it out and added all of this code with a bunch of to-dos. Yeah, so this will probably need to be done in multiple steps rather than just iterating through the pixels. You probably need to iterate through the pixels, figure out something, some information that we pull out of them, and then we go through that information, and then we build out all the polygons. Something like that. Because going through each pixel, that just doesn't make sense. Alright. Start pulling. Well, actually, not start pulling, continue pulling. Collision from art. Okay, well, that's all for today. Thanks, everyone.